solve the inequality and graph the solution set. Now this is a compound inequality because there's actually more than one. So the instructions should have had solve the compound inequality. But different books and different looks. So we have two inequalities. Neither one of them has an x solved for, so we'll have to do that for each one. Each of these inequalities is going to potentially have an infinite number of solutions. And then we combine those two answers with the OR keyword to find the final answer, which is also likely an infinite number of solutions. Okay, so let's start with our first inequality of negative 6x plus 1 greater than or equal to 13. Solving for x, let's subtract this 1 first. Negative 6x greater than or equal to 12. Now our next step to solve for x would be dividing by the negative 6. Now, anytime you multiply or divide by a negative number with an inequality, you have to remember to switch the inequality, leaving us x less than or equal to negative 2. All right, so on a number line, hard bracket, because of the equal sign, that's the infinite number of solutions that represent the graph that represents the infinite number of solutions of this first inequality. Let's take a look at the second one. 7x plus 3 greater than or equal to negative 25. Let's solve for x. Let's start by subtracting the 3. 7x greater than or equal to negative 28. Dividing by 7. Now when you divide by a positive number, you do not switch inequalities. So it's still greater than or equal to and negative 4. Okay, on a number line, wow, that is a crazy looking straight line. Let's try that again. Better, negative 4. Greater than or equal to, so it goes to the right. Again, an infinite number of solutions. Okay, so now, in combining these two with the keyword OR, we realize, here's negative 4, and here's negative 2, that we're taking all these values, or all of these values. And what we've realized, since the keyword is OR, that you just have to be satisfying one inequality or the other inequality. It doesn't matter which one. And in fact, there are some numbers, like negative 3, that satisfy both inequalities. So the final answer to an OR a union of inequalities, would be all of the points on the number line that are either covered by one inequality, the other inequality, or both. And in this situation, every single number on the number line is either less than or equal to 2 or greater than or equal to negative 4. So our answer on a number line would be, in fact, the whole thing. So they said solve and graph. The interval notation, which is also commonly asked for, would be the full negative infinity to positive infinity. Now these are soft brackets. Now you might notice the equations. However, with infinities, since this is more of a concept to go forever, you can't use a hard bracket because you can never get there. You can never be equal to that value. And in fact, if you ever did consider that you were equal to infinity, then that would suggest that if you go just a little further, then you would be more than infinity, which doesn't make sense. All right, I hope this helps.